Hello everyone, in this video we're going into 6.2 periodicity variation of atomic size down the group. So in the previous video we have seen how the atomic size varies when we go across the period. Now we are going down the group. So in this video we are focusing on how the size changes when we go down the group for S block and P block elements. So here I take example of 4 different groups, group 1, group 2, group 13 and 14. So as we can see, for group 1, we go from period 1, hydrogen, all the way down to rubidium, whereas there's another one underneath, which is group 6, cesium, but I don't want to involve that one. And then we go for group 2, from beryllium to strontium, group 13, boron to indium, and group 14, carbon to tin. As we can see for the sizes, as we go down the group, they all follow the same trend, which is increases. Size increases. So for all these groups, group 1, group 2, group 13, 14, the size increases as we go down the group. So for group 1 and group 2, so this is S block elements. Whereas for 14 and 13, this is P block elements. Okay, so group 15 until 18 also follow the same trend, but I don't want to include this in the examples sebab sama saja. So we can say that as we go down the group, the atomic radius ataupun atomic radii, okay, so radii is the plural, okay, so atomic radii size increases. So we are going to explain why this is the case. Okay, so I'm going to take group 13. Okay, so group 13 as example. Okay, so from boron to indium. Okay, so first of all, let's have a look. Let's study the electronic configuration for boron, aluminium, gallium, and indium. So for boron, the electronic configuration is 1s2 2s2 2p1. For aluminium, 1s2 2s2 2p6 3s2 3p1. For gallium, 1s2 2s2 2p6 3s2 3p6 4s2 3d10 4p1. So kita follow off-bow principle, ataupun kita boleh susun ikut shell, iaitu 1s2 2s2 2p6 3s2 3p6 3d10 4s2 4p1. So ini dengan ini sama sahaja, kita susun ikut off-bow, tapi kalau yang di sini saya susun ikut number of kita susun ikut principal quantum number. And then for indium is 1s2 2s2 2p6 3s2 3p6 4s2 3d10 4p6 5s2 4d10 5p1, ataupun kalau saya susun ikut susunan principal quantum number, it is 1s2 2s2 2p6 3s2 3p6 3d10 4s2 4p6 4d10 5s2 5p1. Jadi kalau di sini, kalau kita tengok dia punya effective nuclear charge, kita nak explain trend, so kita kena cuba tengok dia punya effective nuclear charge dahulu. So untuk boron, so effective nuclear charge Z tolak S, so Z adalah proton number dia, 5 tolak core electrons. So let's have a look at the core electron S. Okay, so electrons yang bukan outermost electron, so outermost electron dia adalah 2s2 2p1, jadi dia adalah 1s2. Jadi so untuk this one, it is 5 tolak 2, sama dengan positif 3. Untuk aluminium pula, okay, so untuk aluminium, so aluminium it is proton number 13 tolak kalau di sini 3s2 3p1 adalah outermost electrons, jadi dia adalah 1s2 2s2 2p6. Jadi 13 tolak 2 tambah 2 tambah 6 tolak 10, sama dengan positif 3. Manakala gallium pula, dia punya inner electrons, okay, outermost electrons dia pada principal quantum number yang paling tinggi, iaitu 4s2 4p1. Okay, kalau kita susun macam ni lebih nampak lah, 4s2 4p1. Jadi kita kena tolak, so dia adalah 31 tolak 2 tambah 2 tambah 6, 10 tambah 8. Okay, so kalau kita tengok sini leceh sikit, so kalau kita tengok ini 10 18 28 tolak 28 sama dengan positif 3 juga. Jadi kita nampak trend dah di sini. Manakala indium 49 tolak, kalau kita tengok di sini, so ini adalah inner electrons dia, outermost electron 5s2 5p1. Jadi dia adalah 49 tolak 10, 20, 28, 30, 40, 46 tolak 46 sama dengan positif 3 juga. Jadi kalau kita tengok going down the group, dia punya effective nuclear charge dia remain the same. Jadi kita tak boleh explain kenapa size dia semakin membesar melalui effective nuclear charge dia. However, kalau kita tengok number of shells filled with electrons, kalau kita tengok boron ada 2 shell, aluminium ada 1s, 2s, 2p, 3s, 3p, ada 3 shell, gallium 1s, 2s, 2p, 3s, 3p, 3d, 4s, ada 4 shell, dan indium ada 5 shell. Okay, so kalau kita tengok number of shell dia semakin meningkat, jadi kita kena explain menggunakan number of shell ini. So why do atomic size ataupun atomic radii decreases as we go down the group? Okay, ini adalah yang kita nak explain di sini. Kalau kita ingat balik dalam previous video, kita ada 2 efek yang memberi kesan kepada size. Yang pertama adalah shielding effect dan yang kedua adalah effective nuclear charge. Jadi kita akan explain melalui shielding effect. Sebab shielding effect ni, kalau kita ingat semula, okay, shielding effect, okay, shielding effect between electrons of different shells is strong. Okay, jadi stronger compared to shielding effect for electrons in the same shell. Jadi di sini, when we go down the group of the periodic table, the first thing that we notice yang berubah adalah dia punya number of shells filled with electrons. So going down the group of the periodic table, the principal quantum number ataupun dia punya number of shells filled with electrons increases. Okay, dan disebabkan number of shells filled with electrons increases, thus the shielding effect becomes more significant ataupun becomes stronger. Okay, becomes stronger. Okay, and because of this, because of the shielding effect becomes stronger, so dia punya shielding effect tu makin ketara. Okay, electrons in the outermost shell get shielded more effectively. Thus, the outermost electrons experience weaker attraction towards the nucleus. And because sebab kalau kita tengok dia punya electron dekat outermost shell tu get shielded more effectively, thus the outermost electrons experience weaker attraction towards the nucleus. Thus the size increases down the group. Okay, so kita boleh bayangkan macam ni. Okay, so kalau kita nak going down the group, okay, dia punya cara dia, kalau kita tengok size dia semakin besar like that. So this is going down the group. Okay, size dia semakin besar. Jadi kita explain guna dia punya nak hafal, kita guna N size, di mana N adalah number of shells filled with electrons, S adalah shielding effect, A adalah attraction, dan S adalah size. Jadi going down the group, we explain guna N size, number of shells filled with electrons. Okay, number of shells filled with electrons. As we go down the group, it increases. Shielding effects increases, attraction becomes smaller, becomes weaker, dan size increases like that. Okay, now kalau saya nak explain shielding effect ni menggunakan analogy, so we can have a look, we can imagine it like this. So let's say saya ada mentol. So this is mentol. Okay. Okay, so mentol. So mentol lampu dia warna kuning lah kan. Okay, so dia punya cahaya warna kuning like that. Okay, so let's say saya letak satu frosted glass. Okay, so frosted glass like that. Okay, frosted glass tu kaca yang lut cahaya. Okay, lut cahaya. So apa yang berlaku adalah cahaya ni dia dia terang. Okay, so dia terang dekat kawasan yang dalam ni. Okay, like that. Tapi apabila dia lepas satu gelas, dia akan jadi lebih cair. Kemudian kalau saya letak satu lagi frosted glass, cahaya dia akan lebih so cahaya dia akan lebih malap. Okay, so di sini, okay, kalau saya guna analogi macam ni, this frosted glass here, the frosted glass okay, so the frosted glass here, dia adalah analogous ataupun analogi kepada shells dia ataupun dia punya shielding effect. Manakala cahaya ini adalah dia punya attraction. Okay, so kita boleh anggap dia, kalau kita guna contoh shielding effect seperti ini, di mana proton adalah cahaya daripada mentol tu. Okay, mentol dia tu cahaya terang sangat, dia nak tarik. Dan kalau kita tengok, makin banyak kita letak frosted glass, makin malap cahaya dia. Dan kalau kita letak banyak sangat, nanti warna dia dah tak ada, cahaya tu tiada. So it is similar to this. So makin banyak shell, okay, makin kuat shielding effect. So makin banyak kita letak frosted glass, makin kuat dia punya cahaya punya blocking tu, dan makin sikit cahaya yang kita dapat nampak di sebalik frosted glass. So that's what shielding effect is like. Okay, jadi with that said, so in this video we have explained the variation of atomic radii down the group for S block and P block. Jadi saya menggunakan contoh di sini adalah group 13. However, the same explanation can be used for group 14 until 18 dan group 1 and group 2. Thank you very much for watching. So I hope this video is very clear. Kalau ada apa-apa pertanyaan, please don't hesitate to contact me. Thank you very much.